We are live. Okay. So we're going to do this review. We're going to start at the back and work our way to the front. Hopefully we'll have time. We should have time to maybe get through all of this today. So I'm hoping. The reason we're starting on the back is because I want you to see these predictions. I want us to make sure we're getting these predictions down. And so we're going to work from the top, bottom to the top. Blake tossed a coin 80 times. The coin landed on heads 60 times. What is the experimental probability that Blake will toss heads? This problem is just asking you for experimental probability. So I want you to underline the word experimental probability. When we have experimental probability, you have to remember, that's our WIG over A. That's my what I got over all I did. WIG over A. What I got over all I did. What did he get? He got heads 60 times out of how many?
80.
Out of a total of 80 tosses. When you put 60 over 80 in your calculator, you're going to get 3/4. 3/4 is 0.75 as a decimal. It is 75%. And in our likelihood, it would be likely. Okay? It would be likely. That's just the basic probability, experimental probability. Looking at number 14, there are 12 girls and 8 boys in Miss Rogers' class. Each day, she randomly asked one student to take attendance. In 180 school days, what is the best prediction for the number of times the student will be a girl? Well, first, circle the word prediction. Because if we have a prediction, we know we're going to have a probability ratio and a prediction ratio. We know that we're going to have a variable of x right there. The key here is to determine, is my probability ratio experimental or theoretical? And what you have to decide when you read these questions, in order to determine if you have experimental or theoretical, is, has it happened? Did we do something? Now, Miss Rogers has got these boys and girls in her class, and she's going to do this every day for 180 days. But has she done it? No. So if she hasn't done it yet, and we have not conducted an experiment, what kind of probability are we going to be dealing with?
Theoretical.
Say it loud. Theoretical. Okay. So if we're dealing with theoretical probability, then we're looking for what I want over all I have. And I want you to come right out here and put theoretical. T-H-E-O. Theoretical. And that's why we're using what I want over all I have. What do we want? We want girls out of all. How many girls do we have? 12 girls out of how many? 20 students. And how many times are we wanting to predict? How many times we're going to be doing it?
180.
We're going to do it 180 times. Stop right there. Look at what I just did and tell me if you have any questions about any. Oh, you're kicking. You kicked our camera. Sorry. Feet's got in the way. You're not in the camera. You're not in the frame. I don't have any faces in the frame. Just hands. Be careful. You can move aside. You can move around if you need to and sit straight on this. If that don't help. All right. So, anybody have any questions? All right. So let's cross multiply. We cross multiply starting with the variable. X times 20 is 20x. 20 times 180. Who's got it? 2,160. 2,160. Divide both sides by 20. And what do we get? 108. So, out of 180 days, Miss Rogers should get a girl 108 times. Now, is she guaranteed to do that? No. That's based on the theoretical probability. Okay? Take about 30 seconds and get that down, and then we got to move on. Does anybody have a question about that? All right? I got to scroll up, so it's fixing to go away. If you were to miss getting something that you needed, you can always go back this evening and watch this video. Number 13. All right, 13. Jaden conducted an experiment with a spinner. All right, what's it telling me? He conducted an experiment. So automatically, I know I'm dealing with what? Huh? Experimental probability. I am dealing with experimental probability. The results are shown in the table. So he got the number 1 8 times. He got the number 2 4 times. He got the number 3 5 times. He got the number 4 3 times. Okay, these would have been his tally marks. Based on this data, how many times can Jaden expect to spin a 1 in the next 20 spins? Okay, well, we're doing experimental. So, experimental probability, but we're also doing a prediction. So this is an experimental prediction. An experimental prediction. So that means I'm going to have a probability ratio over here. I'm going to have an experimental probability ratio. And I'm going to have my prediction ratio over here. My experimental probability ratio is going to be what I got out of all I did. Wig over A, because it's experimental. All right, and we're looking at the number 1. So right here, the number 1. So, how many times did he get a number 1? 8. There's your wig right there. 8. I got 8. I got 1 8 times. Out of all I did, so I've got to add these up. And how many times did he spin the spinner?
20.
He did it 20 times. So this is my aid right here, out of all I did. And I want to know how many times he's going to do it when he does it 20 more. Okay? So we cross multiply and we get 20x equals 160. Divide both sides by 20. And x equals 8. Now, it just so happens that this worked out to be the same. Most of the problems you have like this, when you add these right here, that number right there is not going to end up being the same as the number of trials or whatever, okay? The steps are the same. 160 divided by 20. 160 divided by 20. Any questions about that one? Look at number 12. A light bulb manufacturer found that out of 200 light bulbs, 15 were defective. How many light bulbs should the manufacturer expect to be defective out of 2,400? What do you think? Are we doing a prediction? Yes, we're doing a prediction. We know we're doing a prediction. So we can put a prediction right here. We know we're doing a prediction. So we know we're going to have a probability ratio and a prediction ratio with an X right there. Now, have we done something or not? Did we do something?
Yeah.
What did we do?
We did 200 light bulbs.
We inspected some light bulbs, didn't we? So if we've done something, what kind of probability is that?
Experimental.
It's experimental. So we're doing an experimental prediction right here. And with an experimental, we've got WIG over A. What I got over all I did. What did I get? How many times did I do it?
15.
Right. I looked at 200 light bulbs. So that's all I did. I did 200. I picked up 200 light bulbs and looked at them. What did I get? I got that 15 of those 200 were messed up. So now I'm going to say, now I want to predict, because I don't want to have to, do I want to pick up 2,000 light bulbs? No. So I'm going to do a prediction and to predict how many I think will be messed up out of 2,400. And this is something that could very easily be going on in a plant somewhere, making light bulbs. Somebody might have the job of looking at all the light bulbs, deciding. Do you want to be the person that had to pick up 2,000 light bulbs and see how many of them are messed up? Would you rather be able to set up something like this and be able to make a prediction? Okay? So, when we cross multiply, we get 200x equals
36,000.
30 what?
6,000.
36.
36,000. Okay? Divide both sides by 200. And x equals?
180.
180.
So I can predict that out of 2,400 light bulbs, 180 of them are going to be messed up. Is that going to be exactly what happens?
No.
Nope. But when I'm ordering light bulbs, I can make sure that I take into account that I could have 180 of them defective, right? So if you want to know how does this work in real life, there's a good example of that. All right, does everybody have this? Give me questions. Anybody? Do you see the process for going through and determining experimental versus theoretical? All right, I'm going to have to clear it, move it up. If you need to go back tonight and watch it, you can. All right, so on this next one, I have actually put this together a little bit for you. All right, so on this one, here's what's taking place on this particular problem. I have taken and I have put, I'm going to shift that just a little for a minute so everybody can see what we're doing. I put the name. I've done this. So here's Ledbetter. What's her name? Sarah? Sarah's putting these letters on little cards like this. She's writing one letter on each one. Okay? All right, she's got Ledbetter. She's going to take those cards and put them in a basket. Sarah wrote a letter of Ledbetter on a separate index card, put them in the box. She picks one letter at random and puts it back. And then repeats the experiment. If she performs this 90 times, what is the best prediction for the number of times that Sarah would pick a T? Now, what is your first reaction or your first thought on what kind of probability we're dealing with right here?
Experimental.
Why are you saying experimental?
Because it says she wrote it, she already did.
Because it says the word experiment in the problem, right? Well, has Sarah done it yet? Has she done it?
Yes.
Wait, when? Has she reached in the basket and pulled the letter out yet? No. If one little bitty, itty bitty, tiny, 2-letter word, if negates and makes the word experiment kind of go away. The word if, right here. The word if, right here, makes that non-existent. Makes that non-existent. Because she hadn't done it yet. Huh? You can, yeah, I would put whatever notes. She hasn't done it yet. So if she has not done it yet, she's going to do an experiment, but she hadn't done it yet. And if she has not done it yet, what does that mean? We are dealing with. Say it loud. That means we are dealing with theoretical probability. Okay? And we are doing a theoretical what? A theoretical prediction. So, we have what I want out of all I have. Okay? What I want out of all I have. What do we want? I want a T. I want a T out of all the letters. Don't I? How many T's are there? There are 2 T's right there, aren't there? There are 2 T's out of how many? There are 2 T's out of 9. And how many times is she going to do it?
90.
See how the wording, you've got to really look at the problems and decide, have I done it or am I going to do it? Have I done it or am I going to do it? Is it what I want if I do it or what I got since I've done it? Does that make sense? And you've got to be able to differentiate between those two. That's going to be key. Starting here, 9 times x is 9x. 2 times 90 is 180. Divide both sides by 9. And x equals 20. So she can expect to draw the letter T 20 times when she's doing it 90 times. Okay? Does that make sense? Okay? Look at number 10. I want a new color. And Ariana rolled a number cube 20 times. Did she? All right. She rolled a number cube. She has done did it. According to Landon, she already did it. If she's already done it, I should have some data, right? And what is the next sentence? The cube landed on the number 3 6 times. Well, look at there. She landed on the number 3 6 times. I got some data now, hadn't I? So what kind of probability are we dealing with right here? Has she done it?
Experimental.
Has she done it?
Yes.
Yes. If she's done it, what are we doing?
Experimental.
Experimental. This is experimental probability. This is the experimental probability. Now, look at what this says. If Ariana rolled the number cube another 80 times, how would the experimental probability compare to the theoretical probability? So this is asking us to do both. The problem itself gives us experimental data, doesn't it? So we've got to look at the experimental probability here, and we've got to look at the theoretical probability here. Okay? We got to do both because it wants you to compare the two. So let's go ahead and jump over here and look at theoretical for a minute. What I want out of all I have. My experimental bridge map is my wig, what I got out of all I did, right? What do I want? The number 3 out of all numbers. Now, theoretically, on a dice, if I haven't done anything, if I have not conducted an experiment, and I pick up a dice, what is the probability of rolling a 3? 1 out of 6. There's 1 3 out of 6 numbers. There's 1 3 out of 6 numbers. Well, let's see if that happened. She did it. What did I get? I got, she rolled it 20 times. Sorry, I did that. She rolled it 20 times. She got it 6 times out of 20. So we simplify that. We get it to 3/10, right? Now, I don't know about you, but comparing those two fractions, messing up my head. What would be easier to compare? The decimals. So change 3/10 to a decimal, and you should not have to do that on a calculator because it would be that. Change 1/6 to a decimal. What do you get?
0.16 repeated.
So about 0.17, 0.16 repeating. So this is, all right, so let's take it one step further and do the percent. I'm going to move my decimal 2 places, and so this, experimentally, she got it 30% of the time. Experimentally, she got it 30% of the time. Over here, it's 17%. Theoretically, she should have only gotten it 17% of the time. But when she actually did it, she got it 30% of the time. So the theoretical probability is considerably less than the actual experimental probability. It's almost half, isn't it? 15% would be half. She got a 6, almost twice as much as what she should have gotten it. Okay? Whatever sentence you write, because I think this is a lot like the extended response question on the mastery check. If it's not on the mastery check, I know it's on your unit test. You're going to hear this question again. So, they're singing happy birthday to somebody over there. So you can say the experimental probability is a lot less than the theoretical probability. The experimental probability is 17%. The theoretical probability is 30%. The percentages are the easiest to compare, don't you think? Okay. Any questions about that? All right, number 9. Ariana rolled a number cube 20 times. The cube landed on the number 3 6 times. What is the experimental probability that Ariana will roll a number cube 3 the next time she rolls? All right, so we did it. It's right here. This is the experimental probability. So I'm just going to draw an arrow right there because we've actually, so if we were doing these problems in order from If we'd have done number 9 before we did number 10, we would have had the experimental probability already. But the experimental this problem and this problem actually go together. And so the experimental probability was 6 out of 20, which is equal to 3 out of 10, which was 0.3, which is 30%. Okay? So we'd already done it right there. Questions? Is that the last one on the back? Okay, when we go to the front, we're going to jump up and go to number 1. All right? We're doing good. We're probably going to get through the whole study guide, which is good because first period did not, and so this will give them the whole entire study guide. All right? Everybody got these? Huh? You got 30 seconds. We still good on the video? Where are you? Huh? All right, well, if you're not through with all these notes, you can watch the video tonight and get them off the video. Okay? So, let's go up to number 1. Number 1. All right, so y'all try to keep up so you can get as much as you can. But if you don't have all the notes, you'll be able to get them off the video tonight if you need to, okay? I'll put as many of them as I can on here. All right, number 1. Marco has a spinner that's divided into 6 equal sections, numbered 1 to 6. What is the theoretical probability that the spinner will show a number less than 5? Theoretical probability. Theoretical probability. So I want you to underline the word theoretical probability. Theoretical probability tells me that my bridge map will be what I want over all I have. Theoretical means what I want over all I have. What do I want? A number less than 5. I want you to circle that and put WIW out beside it. That's what I want. Divide it into 6 equal sections. Put a certain square around that. That is your all I have. Okay? I want a number less than 5. It's numbered 1 to 6. So what numbers do I want? I want a number 4, a number 3, a number 2, or a number 1 out of all of the numbers. I want a number 4, 3, 2, or 1 out of all the numbers. How many numbers is that?
4.
That is 4 numbers out of a total of how many? Out of a total of 6. So that is 2/3. When we write that as a decimal, it is 0.6 repeating, which would be 0.67. Check me on that. I know I'm right. But which is 67%, and we will call that likely. Okay? Questions? Just copying this down is not enough. Make sure you know what you're writing. Does anybody have a question? Caitlin has a set of cards numbered 1 to 20. If she draws a card, what is the probability of choosing a 7? Caitlin's going, if she draws a card, if she draws it, does that mean she's already done it?
No.
Means she's gonna do it, right? So if she's gonna do it, what are we looking at?
Theoretical.
We have theoretical probability right here. I want you to write theoretical right there. Theoretical. And theoretical probability is what I want over all I got. The probability of choosing a 7. That's your what I want right there. She has the set of cards numbered 1 to 20. There's your all I've got right there. What do I want? I want the number 7 out of all cards. How many 7s are there? Huh? 1 out of how many? There are 20 cards numbered 1 to 20. So it's 1 over 20. 1 over 20. 1 out of 20. Now, I'm going to show you something. Let's go ahead and get the decimal. 1 out of 20. That's 5. That's 0.05 as a decimal. Move that decimal 2 places. That's 5%, which we are going to write as unlikely. Now, I need you to understand something. This right here and this right here are critical. Because the most common mistake people make when doing these problems is it reading it says, what's the probability of choosing a 7? And they write the probability as 7 out of 20. It's not 7. We want the number 7, but there's only one card in there with the number 7 on it. But 7 out of 20 is a mistake that is very, very, very common. But if you will write it the way I've got it written and talk yourself through it the way I'm doing this, you won't make that mistake. I want the number 7 out of all numbers. How many 7s do I want? How many 7s are there? There's 1 7 out of a total of 20 numbers. Okay? Anthony has a quarter in his pocket. What is the probability of him flipping heads? Now, you probably can tell me that right off the top of your head, but we're going to still set it up. Has he flipped that coin?
No.
Huh?
No.
So is this theoretical or experimental?
Theoretical.
This is theoretical. So, theoretical is what I want out of all I have. What do I want? I want heads out of all sides of my coin. How many sides of my coin have heads on it? 1 out of how many sides? 2. So the probability is 1 out of 2, which is 0.5, which is 50%, which would be as likely as not. As likely as not. It's as likely to happen as it is not to happen. It also can be an even chance. But I'm going to tell you something. When you have, this is a very common phrase you will see for even chance. As likely as not is a very common phrase that you will see for even chance. Okay? Questions? Luke has a fair-sided cube. A fair-sided cube. I'm going to change my color. A fair-sided cube. What is that? What is a fair-sided cube? What is this? That ain't nothing but a dice. It's a dice. Don't let fair-sided cube mess up your head. It's a dice. Okay? It's a dice. When he rolls it, what is the theoretical probability of rolling an even number? So, has he rolled it?
No.
When he rolls it, he ain't done it yet. So if he hadn't done it yet, what are we looking at? Theoretical probability. Y'all starting to get the hang of this, aren't you? Theoretical probability is what I want over all I got. Rolling an even number. Here's your what I want. So an even number means I'm going to want a 2, a 4, or a 6 out of all numbers, right?
Right.
How many numbers is that?
3.
Out of how many?
6.
A dice has 6 sides. Unless they tell you otherwise, you can assume that it is a 6-sided. Even if it says fair-sided cube, if it says number cube, if it says number, whatever it calls it, If it's a dice, it's got 6 sides, okay? 3 6 is going to simplify to 1/2, which is going to be 0.5, which is going to be 50%, which is going to be as likely as not, or an even chance. Questions? You starting to kind of get the groove? This is simple probability. Now we got to go to compound probability Monday. I'm hoping that it won't take you long to do the mastery check tomorrow. We can start compound tomorrow. Compound's easy. All we're going to do is take one simple and put them together with the word and. So instead of having one side, we'll have 2. Okay? Now, I got to clear it. So if you need it, you'll have to go back to the video tonight to get it. 5, 6, 7, and 8. Okay. Daniel has a deck of cards. What is the probability of his teacher catching him with a diamond or a heart in his hand? Now, remember that deck of cards I was telling you about? First of all, have we done anything yet?
No.
So what kind of probability are we looking at?
Theoretical.
We got theoretical probability going on right here. All right, so a deck of cards has how many cards? We have 52 cards in a deck. Now, you're thinking, I don't know how many diamonds. I don't know how many hearts. Think about something for a minute. How many?
13.
Think a minute.
13.
Diamonds and hearts are the only cards in this whole deck that are red. You got diamonds and hearts, clubs and spades. Okay? So if you're looking at all of the red cards, okay, you got it in your head? But we're going to write it on here just in case. There are 13 diamonds in a deck, and there are 13 hearts in a deck.
That'd be 26 total.
It's half the deck. Half of the deck of cards is red, half of the deck of cards is black. 13 black spades, 13 black clubs, 13 red hearts, 13 red diamonds. We've got theoretical probability, so we're doing what I want over all I got. What do I want? I want a diamond or a heart out of all my cards. A diamond or a heart out of all my cards. There are 13 diamonds. There are 13 hearts. So how many cards am I looking at?
26.
I want out of how many?
52.
When you simplify that, you get 1/2, which is 0.5, which is 50%, which is as likely as not, which is an even chance. Okay? How many of you would not have been able to answer that problem had you not done the cards with the lab the other day? It's okay. I know. The very reason the last page is on that lab, because it wasn't to start with, and I added it, I think, 2 years ago. Miss McCullough spins a spinner divided into 4 equal sections numbered 1 to 4. Write a vocabulary word that describes her chances of landing on 1 or 4. Another way to say that question is, what is the likelihood? So in other words, what is the likelihood? Well, first, let's just get the probability. Let's figure out what the chances are. Then we'll get to the vocabulary. Okay? Let's do the probability. Then we'll deal with the vocabulary. Okay? So, has she done it?
No.
Is she gonna do it? So, what are we looking at?
Theoretical.
We got theoretical probability going on right here. Theoretical probability going on right here. Which is what I want over all I got. What do I want? I want the number 1 or the number 4 out of all numbers. How many 1s and how many 4s are on there? There's 1 1 and there's 1 4. So that's how many? 2 numbers out of how many? Huh? 4 equal sections is your all. Landing on 1 or 4 is your what I want. So how many? 2 out of 4. Which is 1/2. Which is 0.5. Which is 50%. Now we're to the vocabulary. What do we call that?
As likely as not.
As likely as not. Or an even chance. Miss Callahan rolls a fair-sided cube. What's a fair-sided cube?
dice.
Just a good old dice. A dice. A fair-sided cube is a dice. Write a vocabulary word best describes her chances of rolling a number 1 through 6. All right, so let's look at it. Let's look at this. Has she done it yet?
No.
So it's theoretical. What I want out of all I got. Rolling a number 1 through 6 is your what I want. So I want a number 1, 2, 3, 4, 5, or 6 out of all numbers. Okay? How many numbers is that?
6.
That's 6 numbers out of how many? A total of 6 numbers.
Would that be like 1?
That would be like 1. Which is 100%. And what's the vocabulary word? It is what? It's certain. We are certain to get a number 1 through 6. If we roll a dice, we're going to get one of those numbers. All right? What is the probability of me rolling a 7?
None, because there ain't on there.
What?
0.
Oh, no, that's possible.
Impossible. That is impossible. Impossible. Okay? That question's on there somewhere too. I don't know if it's on the mastery check or if it's on that question's somewhere. But it's impossible to roll a 7. Isn't it? All right. Miss Bosworth has a bag of milk chocolate M&Ms. Write a vocabulary word that describes her chances of choosing a peanut M&M.
Impossible.
Impossible. Can I get a peanut M&M from a bag of regular old milk chocolate M&Ms?
At least the manufacturers are like spec.
All right. Impossible. Okay? Questions? Anybody?
We're done.
All right. That's your study guide. That's your review. All right, before I turn the video off, we're going to talk through how you're going to use this. Today, when you go home, on the Google Classroom, there's going to be the key to the review, the video for the review, and a blank copy of the review. You're going to go home, open your Chromebook, pull up the blank copy. Well, no, first I'd pull up the key, double check it, especially first period because they didn't get the front. Then you're going to pull up the blank copy. And you're going to try to do the review again on the sheet of paper somewhere. You're going to use it as a practice test and practice again. And then you're going to check it either with your paper or the key that's on Google Classroom. And then you're going to see the ones that you missed, and you're going to go back to the video and watch me do those problems again. And then you're going to go do something for a little while. just go play, get on your game, play for it, and whatever you do. Then you're going to come back and you're going to do the blank review again. See if you can do it now. See if I let myself forget about it, can I come back to it and remember it? Or at least do the ones you missed again. See if you remember how you do them. Check yourself. If you still miss them, go back to the video. You see this cycle?
I ain't got a calculator.
All right? The calculator on your phones will do the math that has to be done for this unit. Okay?